In the vastness of the universe, we find ourselves immersed in a symphony of stars and galaxies that seem to have no end. We estimate that there are hundreds of billions of galaxies, and each one of them with 100 billion stars. It is as if each star were a beacon in the inconceivable vastness. If we take the total number of stars, there could be 10 sextillion. There are more stars than grains of sand on all the beaches of the earth. It is impossible to imagine such an abysmal number in that great cosmic ocean. Today I invite you to immerse yourself in an exciting intergalactic journey, reaching speeds close to the speed of light. It will be a scientifically correct journey, applying the laws of relativity in quantum physics, and we will go to such an extreme that you will see that everything you have been told about the speed of light was wrong, and that the universe is stranger than we can imagine. To give you an idea of the vast space we inhabit, if each star in our galaxy were reduced to the size of a grain of sand, the next one would be more than 9 kilometers away. From this perspective, the rest of the galaxies would be dozens of thousands of kilometers away from us. We are just a speck of dust in the vastness of space. And if that were not enough, the universe forbids us from reaching the speed of light. It is as if we were condemned to live forever locked in our solar system. Exotic physics has offered us solutions and shortcuts to travel to the stars. One of the solutions is warp drives and wormholes. These methods are impossible today and possibly in the next generations, but even if we use these methods, they are not fast enough to leave our galaxy. Surprisingly, there is a method that uses relativistic physics that could allow humans to travel between galaxies. But it is like making a pact with the devil, and it has its consequences. And we may not want to accept it so quickly. Let's imagine we have a spaceship that has perfect shielding that is able to withstand any impact and irradiation. This ship can constantly accelerate at 1g, which is as if we were being pushed forward with the same force as we feel the gravity of the Earth. This would create a feeling of artificial gravity inside the ship, which would make life there more comfortable for the crew. This ship would be able to travel faster and faster over time. It is a generational ship that is going to undertake an incredible journey to the stars and beyond. We accelerate at 1g, because if we were to provide a boost at maximum speed like light, inertia would crush us. At 1g it means that our speed increases by about 10 meters every second, so for example after 10 seconds we will travel at 100 meters per second. At 100 seconds our speed will be 1 kilometer per second, and so on. It seems slow, but it is not that slow. With this method we have reached the moon in just over 2.5 hours. And our speed is already 86.7 kilometers per second and continues to increase. It is almost 8 times faster than the maximum speed reached by the Apollo spacecraft. The intrepid crew members do not notice anything special inside the ship. They enjoy comfortable artificial gravity thanks to the constant thrust. Communications between Earth and the ship only take a few seconds, and we are still in contact with our friends and family. Incredible, but a day and a half later we have passed the orbit of Mars. Our speed is already over 1,000 kilometers per second, and we smashed the Parker probe's speed record by 176 kilometers per second. A ship with constant thrust is an enormous challenge, and it would be impossible to carry enough fuel. The most promising project is the Bussard ramjet that would collect hydrogen from the interstellar medium and generate a nuclear fusion reaction. However, the collector would have to be gigantic, tens of thousands of kilometers long. Communications from Earth take half an hour to reach us, and if we respond another half hour, that keeps the crew distracted. It's been almost 26 days, and the generational ship is almost 23 light hours away from Earth. We have surpassed the distance of Voyager 1. Which took 47 years, and we have become, in this theoretical experiment, the most distant ship in history. Our speed at this moment is already more than 21,000 kilometers per second. That's a little more than 7% of the speed of light, faster than any ship we've ever built, but still not fast enough to notice relativistic effects of time dilation. As we move away from the Sun, it appears dimmer and we enter the Oort cloud, heading towards Alpha Centauri. The speed reaches 30,000 kilometers per second, and with each passing day the speed of the interstellar ship travels 3 million kilometers per hour faster than the day before. We have approached 10% of the speed of light, and inside the ship, time dilation is beginning to be noticed. Inside the ship, time passes more than space in relation to the rest of the universe and the Earth, even if we don't notice it. The crew is kept alive with virtual entertainment that simulates the conditions of life on Earth. Several months go by and it is impossible to communicate with Earth in a reasonable time. Due to the time lag and the distance, communications take many months to receive a response. The ship is slowly disconnecting from the rest of the universe. Kinetic energy increases, and that means it is more difficult to accelerate it. The crew celebrates that a year has passed since the trip began, and the instruments indicate that we have reached 99.99% of the speed of light. We are approaching the maximum speed in our universe for an object with mass. We have traveled half a light year, and here very strange things begin to happen. From Earth they would see the crew in slow motion, while from our ship we would see the Earthlings in fast motion. At speeds close to the speed of light, time dilates according to the Lorentz factor, which is an important part of the theory of relativity. This means that everything you've been told about the speed of light is a lie. Alpha Centauri is not exactly 4 light years away, it is only for an observer on Earth. Inside the ship, it is less than 4 years, because time has been dilated. Applying the equations, we get a dilation factor of 70.7. This means that for every second in the ship, 70.7 seconds pass on Earth. The crew members look at each other in amazement, because in the ship nothing seems to have changed. It's like being in another alternative reality. From space, the ship itself seems compressed in length. Now if we wanted to land on a planet of Alpha Centauri, we would have to turn the ship about 180 degrees and apply momentum opposite to the movement. But most of the crew refuses and rebels. They want to go further and faster where no one has gone before. We will never be able to see all the planets and stars in a human lifetime. If we visited 1 star per second in a human lifetime, we would only be able to see less than 1% of the stars in our galaxy. Now, with a Lorentz factor of 70, we travel the 4 light years that separate us from Alpha Centauri and pass the system in 21 days. Although on Earth's clocks 4 years have passed, that is the extraordinary effect of time dilation at speeds close to the speed of light. The speed of light does not seem slow, since time is the decisive factor. It is somewhat surreal, because in the next few months we receive messages from our friends and relatives who are getting older and older. Events on Earth are happening with incredible speed. On the ship it has already been 1 year and 3 months since our departure, but on Earth it has been 17.6 years. There are still corrupt politicians, paranoid ex-presidents, and more stupidity. More technology. But in mentality nothing has changed, they are worse than ever. Maybe we can increase the speed to 99.9999% of the light. Any change, however small, causes us to increase the time dilation, and the Lorentz factor increases by more than 1500. We have reached Orion's belt in just 88 seconds, while on Earth more than 1,500 years have already passed. Those in space watch fascinated and amazed. We make contact with Earth, and the crew is shocked to see the drastic changes that have occurred since we left Earth. Now the time lag is greater. Only 1 year and 3 months have passed on the ship. We must move on and leave our galactic arm. We have time in our hands, and our clocks are going slower and slower compared to the rest of the universe. We continue to increase the speed, and with it the Lorentz factor multiplies, and here something very strange happens. At speeds so close to the speed of light, we see our field of vision contract until it becomes a tiny tunnel-shaped window. It is as if the ship had captured the attention of the universe. In particular, as the ship approaches the speed of light, the wavelength of the emitted light is greatly compressed towards the blue end of the spectrum. This is known as relativistic blue shift. It's like having the universe in the palm of your hand. This was already mentioned by Carl Sagan in the documentary series Cosmos. The intergalactic ship, although it does not reach the speed of light, is very close to it, and time goes so slowly inside it that it only takes the crew a few hours to reach the Andromeda Galaxy. But for Earth more than 2.3 million years have passed. It is difficult to imagine how the Earth has changed in that time. We no longer have any kind of communications. It is surely already deserted of humans. Nature must have recovered, and the diversity of life is higher than ever. However, All that remains of human beings is on this ship and stored in the main computer. We are in the local group of galaxies, which spans about 10 million light-years in diameter. We are now realizing that there are no limits to distances when traveling at near light speeds. The only problem is time and the time lag, which is increasing. We have left our local group and the Virgo cluster with Earth time of 65 million years, and only 1 year and 4 months since our departure. The distances are becoming larger and larger. It is as if the cosmos wanted to escape before our eyes. We are exactly witnessing the expansion of the universe in fast motion. The crew are the only humans left in the universe. A small group of them panics. We are a species that needs to expand, communicate, and learn from our environment, and now we only have a one-way road. The crew is torn between reaching a habitable planet in any galaxy or continuing on. In a desperate moment of the collective, they increase the speed even more and the Lorentz factor shoots up. The universe seems to compress even more before our eyes. We travel the vast galactic distances at 100 million light-years per second. Although seen from the outside, we have not exceeded the speed of light. We have passed our galactic continent Laniakea. 1 billion light-years, 5 billion light-years from home, we are dangerously close to the cosmic point of no return. As soon as you cross it, you don't and you return home, even traveling at the speed of light, and that's because the universe is expanding. That point is located about 8.3 billion light-years from Earth. It's like being submerged in a black hole. The crew can't believe what they're doing. Once past the cosmic point, there is another limit zone. In the universe there is an area called the cosmic event horizon, about 16 billion light-years from Earth, a distance from which a ray of light emitted will never reach us, and no matter how much we accelerate we will never be able to reach this event horizon. This is because parts of the universe are expanding at the speed of light. Which means that the distances between us and those parts of the universe are also increasing that speed. So even if we travel faster, the universe also expands even faster, keeping that distance unattainable. At this moment a strange feeling runs through the crew of the intergalactic ship. No matter what happens they will never be able to return home. All our friends and family have died. Even the human species does not exist. Since we cannot return home, let's change the rules and continue to the end. Relativistic physics rules prevent us from returning to the past. We have to follow the laws of entropy of disorder. The intergalactic ship travels distances of dozens of billions of light-years. Once we reach this point, we are no longer really a spaceship, we are a time machine. We are increasingly isolated and trapped in a vacuum. The universe has expanded so much that there is nothing in the observable universe except the ship and the crew. No matter how much we increase the Lorentz factor, we are trapped in the immensity of the vacuum, and we will never be able to reach other galaxies or any habitable planet. Time outside the ship is moving at a rate of millions of times faster. Trillions and trillions of years have passed out there. The brave crew members continue to increase the speed of the ship to infinity. Because there is no way to reach the speed of light, and in our miserable and poor existence, not even the Lorentz factor is able to stop the aging of the crew. Hundreds of years and several trillions of millions pass in an empty universe, where even the cosmic microwave background has disappeared. The new generations can adapt to the space environment better than their parents and grandparents, and they will understand according to the database that they came from a small world called Earth, the home of their ancestors that became extinct, and that they were traveling in a ship through a void without direction, totally lost, something terrifying. And despite being a generational ship, technical problems, diseases and genetic mutations lead us to extinction in several generations due to our lack of expansion. What comes next is terrifying. The universe is being compressed and has been reduced to a spheroidal region of a few kilometers in diameter. The temperature is increasing so much that the ship is disappearing from existence, as if it had never existed. Everything is becoming a singularity of energy, until finally the remains of the poor unfortunate humans are reduced to a mass of energetic particles. Congratulations, you have reached one of the possible ends of the universe, a big crunch, according to theoretical physics. This is one of the fateful effects if we traveled far enough at relativistic speeds. If we travel too far, we end up disconnected from the rest in time and space. We could even witness the end of the universe, and everything starts again like a reboot. The beginning is the end, and the end is the beginning. This physics is somewhat speculative, but it makes us wonder how many times the universe has transformed itself again and again. The universe in its immensity and time surpasses us on all fronts. If we challenge its limits, it becomes strange. It is as if a program were turned off. We do not know if this will be the method we will use to travel through space, but one thing is clear: time is against us, and we will need to expand to survive, either on various planets in the solar system or on nearby stars. The further away we are from each other in the vast space, the more vulnerable we are. To the universe, we are very similar, insects, and we should enjoy a universe in its infancy while we can. It is a special moment in which everything seems to be united and life is possible. We are in the best possible scenario to enjoy this moment that the universe has given us. We must use time wisely, unite as a species to achieve the impossible.